recording. So the second part of the observer is, well, our observer class is good, our subject class is good, but the big issue, our subject is big, it's an airplane. What actually happened is a lot to check, right? What I mean is, so if we go back into our airplane here, we go back to our airplane, it has a lot of different actions that it could do, and depending on your subject, it could have even more than that. So right now our subject, which is the airplane, it could only start the motor. Actually, we have the project structure here. It could only start the motor, stop the motor, take off, increase altitude, decrease altitude. Nothing really, anything else that makes big a change. And if we were inside the GUI, you'll notice right now we're just doing two things. But with just those two things, it's not enough, right? So if we look at our airplanes, we need to do a bit more than just increase, decrease. We need to say, well, you're in the danger zone. Well, we need to do a lot of if statements. We need to check which one he clicked, so we could say that he just took off, or if there's an error, we should display that, etc. But this is a bit too complicated. Well, actually, it's not complicated. I could just do all of those checks here, and then it becomes a big 40, 50 lines for something that we could have made a bit more precise. So rather than saying airplane got updated, we could say what got updated. Rather than saying our YouTube channel got a new video, we could say our YouTube channel got the new video about dogs, and this is the link to it. Rather than saying Instagram, this user has added new pictures, we could say this user added this picture, this picture, this picture. We could show them, specify them, right? So our updates, well, actually, let's go look at our subject. Our notifying the observers, we could send a bit more information into this update, right? So at this moment where we want this to be a bit more specific, we could do two things. Well, now, again, because we're inheriting it, we could either overwrite this class or even make it into a interface where he deals with it. But to be honest, I kind of like this because this stuff is not going to change, and I don't think it really needs to be an airplane for that. So we could keep that here. And this notify observer, we could do two things. One, we could overwrite it directly inside airplane by saying overwrite, and then we go and say public. Well, actually, let's use the IDE to help us out. We're going to do Control O for overwriting, and you'll notice we could override the attach, detach, notify from observer, the subject that we got, and we also have the object by default, right? Everything inherits from object. So we're just going to override this notify observers, right? We could have also done it where we make this completely abstract and forced it to be something. Gotta remove this though. Actually, what am I missing here? Oh, I forgot the abstract word. Here we go. Abstract. Could have made this abstract, which enforces inherited class to implement it, right? So either that, or either we leave it as a default value, and then if need be, we could go and make it a bit more specific. But in this case, let's go make it into a, actually, let's not delete that stuff, but let's go and make it into a abstract class. And I'm doing that because I don't think we should mention it here, especially since we're gonna go and modify the update in a second. So in here, we're still gonna do the same thing. We're gonna go through each of my observers. Sorry, observers. Inside my list of observers. There's another issue I'm having here. Now that this is private, we can't access it, so let's make this protected. And this, we could make it private, doesn't really matter. Actually, we could just take off the abstract. So this, we don't need it private, we can make it private. Sorry, give me 1 second. So we can't do abstract and private at the same time. So the solution is we're gonna make it protected. So the child, actually we're gonna make it public here. No, let's make it protected for now. Sorry. Okay, I'm thinking about stuff and it's not going well in my mind. I'm kind of tired. We're gonna go through all our observers, right? And we're gonna call again the same thing, observer.updates. Okay, but this time inside the update, we're gonna specify something more. What do we want to specify? This is where we get a bit more interesting. So we could specify what changed. Did we increase, decreased, take off, stop motor, start motor? However you want to notify, it's your prerogative, your choice, your ideas. So in this case, let's make it super simple so we don't make it too complicated. We're gonna say when we're notifying, when we're calling this function notify observer, we're gonna mention what just happened, what action just happened. And we're gonna mention inside something simple, we're gonna mention inside a string saying this is the action. And again, because we're overriding something, we need to go here and change it here as well. So the action that happens, we're gonna pass it to our update and let them take care of it. And again, we're gonna say action. And you're gonna notice we're gonna get an error, so we go at observer and we say string action. Okay? So now, when I decrease, I just pass in a decrease. Now, when I, let's see where else we have this. When I increase, I say increase. When I take off, I say take off. When I stop, I say stop. Start, I say start. Okay, and I could have passed an object. I could have passed anything I wanted, really. It's up to us how we update those observers. So again, if you think about it as a YouTube channel, we would have sent them the video link, the video title, the upload, etc., to notify that those subscribers that we added this video into our channel. Someone asked, are you going to talk about reactive programming as well as in RX Java? No, we won't actually be able to reach that part. But to be honest, they're all similar. Just take a bit of time and you could learn them. If you have questions about them, I wouldn't mind. But the framework you use, what you use, the tools you use, they don't really matter. It's the techniques used that matters, right? The languages, there's millions of languages from Java, C++, C#, Go, whatever you want to keep going, Python, you could name. Actually, might as well go off topic for a second. If we go on Google here and we write programming languages, I'm killing off my search history, but whatever. If we look at the list of programming language, actually, let's do list of programming language. And you could go on Wikipedia. You'll notice there is a lot of programming languages. And a lot of that died. A lot of them didn't even come on the list. It doesn't really matter. And most of them, they're kind of a different stuff. So we have the OP styles. We have different paradigms for different languages. And the thing is, the language, depending on the paradigm they use mostly, they're all going to be really similar. Over the years, we haven't went off trail. We kind of take our previous generations. So such examples would be, let's say, I don't know what you guys know, but let's say, see something that's more popular that people used to know. Blah, blah, blah. Just trying to find something that everyone would know. Like lips, actually. Let's go L. There we go. Lips. This is one of the early languages, right? Might still be alive a bit because companies used it and it's harder to pay someone to change the whole system than to just maintain it. So it might still live, but you'll never find a new job with Lisp anymore, right? Might find one or here to maintain stuff. So my point being is languages are used as basis for any new language that comes. And depending on how the language is made and if it actually solves an issue that we currently have, well, that language is going to take over and it's going to be more popular. When Java started out in 1990s year, it was really popular because it had implemented OOP and it was its core usage. And it got a lot of traction and it went up really fast. But to be honest, Java is not the most optimal language, especially now that they have to take care of all the previous versions of Java. So whenever they do a big change into the language, they can't really take out the old stuff. They have to keep it for all the new, well, all the software that's using Java, that's using the old things. They can't just take it away. Otherwise, those the update is gonna make a lot of applications not work. Right? So their system is kind of flawed, and they're trying to clean up and whatnot. It's taking a long time. So I'm not saying Java is bad. To be honest, I'm not like I'm not one of the top gurus who dictates which language should go where. But the fact is, you'll start learning a language and you'll start liking one over the others. So the question didn't mean the language, meant the paradigm of using streams and such. I use similar, but it doesn't follow any name pattern. And again, the name pattern is stuff that was really obvious, these design patterns that we're using. I don't think there's anything specific in RX Java that we need to cover, to be honest. Again, Java is not my thing, so RX Java is even less of my thing. I just wanted, actually not that. I just wanted to read it. Well, whatever. So actually, if you look at observable sequences for the Java, pretty sure they kind of use the same stuff. What we're all talking about right now is really, I don't know RX Java enough to give you a better answer. But what we're basically using is stuff that's going to be used anywhere. So it's not really going to change. If their way of doing things is a bit different, such as upstream, downstream, to be honest, as soon as you understand it a bit more, it becomes all the same anywhere you go. Okay, so like this could be, this is called function, in different languages, this would be called function, wow, I'm really tired today. I forgot the name, but this already exists in multiple applications where whatever's passed, it goes to the next. Gee, I'm not too sure as I'm not reading the whole thing, but you could look into this. You'll see JavaScript kind of does something similar. I'm not reading it, so I can't say. But in this course, at this moment, we are not going to touch this. And to be honest, you could learn this on your own. Take some time. The best thing you could do for yourself is build a project with whatever you want to learn. A big project that you're invested in and that you're interested in, which is the big difference. Anyway, sorry, going off track. Let's go back to here. So now that we send that action to our update, see we're modifying it, customizing it to our needs. Inside the inside the GUI, which is getting the update, now it gets something called action. And now, based on that action, we could do, let's say, maybe a switch. I don't know if it should be actually good. Based on the switch, based on these type of actions we put here, so decrease, increase, all that stuff, we could do something such as, let's say, decrease And the case of increase, we could change the altitude, right? In the case of, actually let's put that a bit higher. In the case of decrease, increase, what else we have? Takeoff. We could also change the altitude, right? In all three cases, the altitude would change, so this is a good part. And at the same time, we could also put it in here, right? In the case of, let's say, stop and start, well, these two, we're gonna have a break, but we could mention what happens in a stop. We could change the LBL. Let's see what do we have. LBL information, set the text, motor stopped. And because we know it's being updated from somewhere else, we could have probably said a bit more, like motor stopped from someone else. Okay? Well, you gotta change the code a bit more, but you could do anything you want. Over here, we could do a break. Motor start. Cool. Over here, we put a break. And here, because we know takeoff, decrease, and increase will change the value, but we could also do a little takeoff explanation, airplane taking off, as an example. And again, we still have to go a bit more details, but whatever we send here could have been even more. We could have sent the message, we could have sent the whole area, depending on our design of airplane. This is why I'm telling you, actually let's run it before we go on. So I'm telling you that observer pattern, even though they specify this or that, in the end, they're just a guideline. In the end, they're just a way of doing things. So now if I start it, you'll notice here it says motor started. Right? If I take off, here it says airplane taken off, while here it says airplane we have taken off. Because this one, the update is going to here, while action perform is taking care of this part. Right? But now it becomes much better. Increase, increase, decrease. Right? And here we could do, based on the increase, we could check if it is, make it yellow, make it red, put the warnings, and so forth, so on. Right? If we wanted to, we could make our subject have, our observer have more than update. So we could have void update, let's say danger. And we could say, let's say we pass in the value of the altitude. And over here, let's go back to our GUI. We have, update. We also do update danger, I think I called it. And here we have altitude. Cool. And now depending if this is called, well then it means we're inside of one of the dangerous scenarios. The dangerous scenarios are altitude reach 10,000, 11,000, or 12,000. So what we want to do is we put it back in here. We want to set the color to, let's say, red for danger. Right? When I set it to red, we want to say get the altitude. Actually, this is LBL information. We want to do LBL current altitude set foreground color to red. Actually, we got the altitude. There's yellow and there's red. Let's do a switch. It always looks better. Altitude switch. Why am I doing case? I'm really tired. In the case of 10,000 and in the case of 11,000, we wanted to make it orange, right? In the case of 12,000, just gonna write it in the below. Actually, well, yeah, why not? Case of 12,000. We want to make it red. Alright, so now we know it's one of these altitudes. Update danger would be either one. I don't know if you guys are following along. And then again, I could print out the altitude and whatnot, but this time it's going to be colored. Right? I could do the same thing with the progress bar. But now, because of having these two functions inside the subject, I need to specify which one I want to call. Do I want to call the danger or the regular? So here I could either make another function, or I could just make a extra parameter that says, let's say, Boolean danger, and by default I leave it to false, but Java doesn't have the default value. So Boolean danger. So now in airplane here, at each one of these things, well, actually first here, Boolean danger, I'm gonna say if danger is true, observer dot update danger, and send in the current altitude, so get altitude. Otherwise, else, I call in the regular one. Right? And all of this I would say false. This is not dangerous. Well, actually, this could be dangerous. I should check it here. I don't know. You do something similar, right? So altitude minus rate of change. It should still be okay. We should do the check inside here or something. Okay? Actually, we could have done that too, where we say, well, it doesn't take a danger. That would be probably easier. Let's go back here. It doesn't take a danger. But inside here, we'll check it ourselves. If the get altitude is bigger or equal to 10,000, then send that with the altitude. Now that looks a bit more interesting. So now if I run it, start, take off, increase. When I'm reaching 10,000, you'll notice here, starts becoming orange or yellow, just like here. Because the observer that's being called, the function in the observer being called is update danger and not just updates. Right? So I could have anything I want. I could call any functions I want. The only thing is to make sure that we have observers and we have subjects. Again, this is an idea. So you change it, you adapt it, you make it more complicated to match what you need. Cool? And that would be the observer design pattern. It's a really important one, because you see it everywhere. We've seen it, we used it even before learning about it. We used it when we were doing the buttons, the add action listeners. See, as a listen list, it adds them, removes them. Let's see what else he does. He gets the listeners if someone wants to know who they are. He has different types of listeners, changed listener. Just going through this, reading the code for, this is the class called abstract button. Let's see what else. So here, notifies all the listeners that have registered interest for notification on this event type. So this is interesting because you could actually register for a specific event, such as, let's say, the button got clicked, the button got dragged, the button got long click, right? The button got long click, but then the mouse went off of it and didn't finish the click. There's a lot of states for just the button. And depending on that, they could do something. So in this case, they're going through each one of those listeners, starting from the last to first for whatever reason. And for each one of them, right? It's doing some other stuff we don't really care for at this moment. For each one of them, is going to call the function action perform. So for each one of them, is going to typecast it to an action listener that it knows for a fact has action perform. Knows for a fact that has action perform. And what's really interesting about that is your listener could be any type. It doesn't need to be always airplane. Sorry, your observer doesn't need to always be the GUI. Our observer could have also been another thing that takes another thing that could take let's say, it prints out to the console. Another GUI could have been a virtual reality, right? Another thing we could have done, let's say, as different examples. Let me go ahead and do some annotation. Another thing we could have done is we have a student, or let's say we have a class. So this is a class, a classroom. And whenever a student gets a bad grade, a couple people need to be notified about it. One of those types could have been, well, let's say the teacher, that's the first one. Even though teacher adds the grade, sometimes it's automatic. So if at any moment that student inside the classroom gets a low grade or something, I want the teacher to be notified. I want to, for some reason, let's say the administrator wants to be notified to know about how the teacher, how's the student doing. So maybe the administration wants to know about this, right? You're the executive people. And another case scenario could also be your parents, because they paid for that classroom. They paid for you to learn. And in those three cases, all of them are interested. All of them wants to know what's going on in the classroom. And at any moment that an event happens, classroom needs to call the update function and all of those ones. So let me see text. So there's an update on this. There's an update on this. There's an update on this, right? But the problem with this is, how does classroom know that teacher, administrator, and parent will always have this update class? This update class, depending on who it is, actually let's erase. Depending on who it is, it might have been called something differently. So administrator would be to administrate the students. The parent would be to yell at the student, or see report card, I don't know, whatever. The teacher was to check grades, let's say. In all three different case scenarios, there's something related to classroom being updated, but the function names would be different. So how would classroom know what it is that it needs to call? What function of these objects, teacher, administrator, parent, would it need to call for all the interested parties? We don't know. This is why we create, draw here. This is actually, let me draw a different color. This is why we create an interface called observer or listener. So here, this would ensure that when all three of them implement the functionality inside, such as updates, that they will all have a function called updates, even though they might have other functions. You guys see what I mean? So teacher is an observer and listener. Administrator is an observer or listener, whatever you want to call it. Parent is a observer listener. So classroom doesn't really know which one of these is the observer. It just knows that it has an update function, and that's what's the important part. Cool? So it doesn't need to know if he has the function check grades, administrator, student, see report card. The only thing he needs to know is they all will implement the function update, update, update. So when classroom has changes, it'll go through the list of observers and call the function update, and maybe in this case would pass in the the student that has updated grade, that has the bad grade, to let them know about it, right? So observer class becomes really useful, interesting, based on what we're doing. So maybe this would be a good assignment. Any questions? So I don't have assignments for. Actually, let's stop the recording.